Okay, so right. The last time we ended with frequency distributions, and what example did we use for the qualitative case? Starbucks. Okay. Now we are going to extend it to the continuous case, and I mentioned that if it's continuous, we're going to organize it into intervals and put them in intervals. So I want you to give an example for continuous data. Something that I can collect here.
Well, you can't collect that.
Yeah, I can't collect that. That's private information. What are you playing with your phone? You. Oh, her.
Me? No.
You know.
Pencil. Like the.
Oh.
Yeah,
Oh, you fitted, okay. Felt like she's going like this. That's all. I want you guys to give an example for continuous data that I can collect information from this class.
Height.
Height?
Yeah.
It'll work, but
Okay.
I mean, let's be creative.
Oh, liters, no, milliliters in our water bottles.
Do we know?
Totally.
You don't have a water bottle.
No, I do.
Okay.
40 of us?
We'll keep that. I think you should do better. Everyone's looking at the
We don't breathe in a minute.
Do you know?
No, but then you have to look at the arrow.
Yeah. And then it's going to be discrete. I want something into.
Heart rate.
Are you happy on one thing?
Oh, yeah.
We could do that, but still we wouldn't get half of heart rate. So. What else? Something that would involve a decimal fast.
No, never mind.
So percentages or battery.
Oh, that's
That's not really good.
That's actually good. We can keep that one too. Do we know?
Yeah.
Okay, well, for this example, let's forget your phone. So the percentage battery left in a student stone at 3 p.m., which is now or close to 3 p.m. during a school day is analyzed. Now, we will do one here, and once you get comfortable, we can do an example from the text. Let's see, we'll start with you.
98.
98. Hopefully this turns out to be a good data set.
98.
Okay.
59.
59.
72.
72. It's getting better.
81.
81.
85.
85.
46.
46.
34.
That's it.
72.
72.
57.
97.
72.
78. 57. 66. 76. 63. 55. 21. 50.
I'm gonna
55.
52, 75, 94,
71.
68.
95,
89.
52,
few more. 73.
61. 77.
77. That's plenty. Good. You can write this stuff down. It's us that we'll do this so that you get a good understanding, and then we could go on and do one from the text. Okay. So our objective is to construct a frequency distribution with 6 classes. In other words, we're going to have 6 levels. So there is a process to construct, so that's what I'm going to go over. In practice, we're not going to sit and create this manually. Things are done using computers. But we do have to understand what a frequency distribution is about. So the process is easy. You start by looking at the maximum value, which is 98. And then you look at the minimum value, which is 21, I believe. So the range is the maximum value minus the minimum value. So 21 minus 98. Or backwards, 98 minus 21. And that is 77. And we want to divide the range by the number of classes. Whatever range that I found, I'm going to divide it by 6. What do we get? 12.8. I think. It's 12.8666.
12.833.
83. Are you sure?
Yeah,
5/6. Wait.
so I'll do it again.
It's okay. I just.
Yeah, that's well.
So regardless, we're going to round it up to 30. So in this process, no matter what number you get, it's better to round it up. Once again, you may say, well, if we round up, round down, or if we make stuff up, well, we're not, because we have a good enough sample, things will correct itself. A very good example, I was teaching time series this morning, everything was going fine. The very end, correlation coefficient went up of 1. We will talk about this at the very end. It shouldn't. And the issue was rounding. Because of rounding, we got an extra bit of value and it exceeded 1. So rounding does affect your conclusion if your sample size is really, really small, but large in the sample size, this is not that big of a deal. So we found the class width. Typically, people would start with the minimum value and add 13 to that value to get the maximum value of the class. So let me write this down. I think your book starts at the minimum value. Now, in practice, people would like to start one less than the minimum value so that the minimum is included. So I'll go with what your book has. So this is the percentage. The minimum value is 21. And we are going to add the class width to it, which would be plus 13. That would put us at 34. The next number, which would be 35. Add 13 to it, it will take us to 48. Next number, 49. Add 13 to it, 62. The next number, 63. Add 13 to it, 76. Next number, 77. Add 13 to it, we'll get 90. Last number, 90. Add 13 to it, it's 103. Of course, we're not going to get to 103.
Wouldn't it be 91 if you're doing?
I'm adding 13 to this.
No, but when you do 90.
Oh, I see, okay, thank you. I can't count. So we wanted 6 classes and things worked, yes.
104.
Done. So it's 104, even though it's not going to go that far. We wanted to get 6 classes and we got 6 classes. Now, between 21 and 34, how many do we have? So 1, 2, just 2. 35 and 48. 1. That's it. $49 and 62. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yes. Keep an eye on it. 63 to 76. We are including that 76. So 1, 2, 3, 4, 5, 6, 7, 8,
70 on the bottom row.
9. 77 to 90. 1, 2, 3. Oops. 1, 2, 3.
Bottom row 77.
4,
Bottom row.
5, and bottom end 6. And lastly, 98, 1, 2, 3, 4. So, yes,
Then just one question, why did you count it from 13? Like, what were you adding?
the width was 13.
Oh,
Our class width was 13. So I'm adding 13 so that the width here. So once we find the class width and the classes, we have this table. This table is what we call a frequency distribution. Just by looking at this table, we sort of understand that the properties at 3 p.m. in the afternoon, what is the most frequent battery level that we could expect from the student?
49 to 62.
somewhere between 49 and 62, similar to what we did last time. The least frequent would be somewhere between 35 and 48, but then this is just as small, so either would work. Excuse me, from here to there would work. Accurately speaking, based on the frequency distribution between 35, excuse me, from 35 to 48. Yes. Last time I did a frequency distribution for qualitative data, moved over to a picture to visualize. And what was that picture? Is no
Bar
Bar
bar graph. So that's for qualitative data. Okay. Now we are talking about numerical data. So if you look at the real number line is continuous. Do you agree? Yeah, there are no breaks on real number line. So when we create a graph for continuous data, the graph is going to look like a bar graph, but unlike the bar graph, there can't be any gaps in between. The bars need to touch and it has to be continuous. One way that we can accomplish that is by doing what we call a continuity correction. Simply means you're adding 0.5 and subtracting 0.5 as you go along. In other words, I'm going to subtract 0.5 here, add 0.5 there, subtract, add, subtract, add. Okay. So that's what we call as class boundary. So I can find a class boundary. And mind you, this is one of many ways to create, a histogram nicely. So here, go from 20.5 to 34.5, 34.5 to 48.5, 48.5 to 62.5, 62.5 to 76.5, 76.5 to 90.5, 90.5 to 104.5.
Thirty.
Do you see what I'm doing? So there was a gap between 34 and 35. I closed that gap by making that correction. Good?
Yeah.
Okay. Now I can sketch a graph. Run out of space. Okay. Works. So, are we done by 10? So for the first class boundary, the frequency is 2. The next one, it's about 1. The one after, it's 11. then it is 9.
Wait, I'm confused. I just,
What part?
where are you getting the, oh, just.
Yeah, the frequency. 76.5 to, are you guys with me? Okay. To 90.56. And 90.5 to 104.5. That's nice. Good. Now, do you sort of see a shape? A staircase? Okay. What else do you see?
Sort of like a bell curve.
Sort of like a bell curve, but it's not a bell curve. Why?
There's very small values on one side.
There are small values on this side. If you know, took starts before bell curve is symmetric, it looks like that, but this is not symmetric. So some of you can look at this and recognize the shape right away. And shape is a very important feature in statistical analysis. So some may not be able to. So what we can do is find something called the midpoint of each class. Now, in other words, we're trying to find the center of those two. Like, what is the center of 20.5 to 34.5?
27.
Huh?
27.5.
27.5. How did you get that? You add these two and you divide by 2, right? So the midpoint 34 plus 20, 54, you have 55 divided by 2, 27.5. What about the next one?
41.5.
41.5. The next one,
55.5.
55.5. The next one,
69.5.
next one,
83.5.
the last one,
97.5.
if you look at it, if you found the midpoint here, it'll still be the same. Do you agree? So because what we did is added and subtracted 0.5, it's not going to change. So you'll still get the same midpoint. So I'm going to, you know, put it in the center. I don't know if it's, you know, properly in scale, but I'm going to assume it is, and the next midpoint and one over here. Right, so one on this side, one on that side. So we can't just connect the dots here. What we have to do is to look at the height at each of those points. So the height here at this point is right there. At that point, it's right there. At that point, it's right there. That one is right there. That is over here. The last one is there. And we bring it back down and put it at 0. Now we do the usual thing, connect the dots. Can't draw a straight line. Not bad. So earlier, we weren't able to see a shape. But now you can see a shape. What does it look like? What? That,
No, different kind.
a triangle? Okay, what's that? I mean, in a weird way, can I say it sort of goes like this?
So it looks like a no.
Huh?
Oh, it's past true.
Here, right?
Sure.
Now, in a very smooth case, it will probably end up like that, because these values are very small. Later on, we will talk about something called a skewed distribution. This one is less skewed, because you have smaller values here, smaller frequencies here, majority of them are right over there. So this is a less skewed distribution. Most of you have battery power that is bigger than 48.5%. Good. That dotted, excuse me, the line in purple. I'll explain what a relative frequency is. The line in purple, it's going to be the relative frequency distribution if we change the frequencies to relative frequencies. In other words, I'm simply going to change those numbers to percents. What does relative mean? If you have to find something relative to something else, what is it? Approximate.
Relationship to.
In relationship to something else, right? So I want to find the relative frequency. In other words, this proportion, this value proportional to some value. What should that value be? How about the total? Right? 2 relative to the total will give me a proportion of that interval. Do we agree? So we have 3, 14, 23, 29, 34 of them. So all we have to do is take 2, divide by the total. 1 divide by the total. 11 divide by the total, and so forth. So 2 over 34, 1 over 34, 11 over 34, 9 over 34, 6 over 34, 5 over 34. You can convert it to a decimal if you want. But it's not necessary because I'm going to show you how to graph this. Probability. So relative frequency is nothing but a probability. If someone came and asked you what percent of students would have their battery power between 21 and 34% at 3 p.m. in the afternoon, it would be about 5.882%. That was the very best value in your calculator for this student. And you can extend it, this would be about 33%, and so forth. Does that make sense? Instead of giving them a fraction, you're giving a percentage. How many of you here love fractions? So fractions are amazing, but people don't like fractions, right? You can't go, if you become a news reporter or a meteorologist, you're not going to go up there and say, so temperature today is going to be between 49 and 62, and the chances of that happening is 11 out of 34. You'll get fired probably because people will not like it. But if you give it as a percent, people will understand. So what is the upper endpoint of that? 34.5. The upper endpoint for this class, 48.5. Upper endpoint for that,
62.
76.5. 90.5. 4.5. Yes. Now, we don't need the relative frequency because we did that, we plotted it against the midpoint. What we want to do is to compute something called a cumulative frequency. What does cumulative mean? When someone says, this is your cumulative rate today.
Everything comes together.
Everything added today, added, right? So up to this class, we're going to add every relative frequency prior to this class, right? Is there a frequency prior to this class? No. So 0 plus 2 out of 34 for the first class, it will simply be 2 out of 34. Yes. Now I'm going to move to the next class and add all the relative frequencies corresponding to that class. So what would that be? 3 out of 34. For this class, I'm going to add everything prior, including this one, 11, 12, 13 over 34. Over here, what would that be?
23.
23.
Oh, sorry.
13 plus 9.
22.
Over here. Yes.
14.
Yeah.
Oh, did I mess up?
Yeah, it's fine.
Oh, 14.
I
Okay.
knew it wasn't.
See, once you get a PhD, you forget position. So add 6,
49.
29 over 34. And the last one would be 34 over 34. That would simply be 1. Now, hypothetically, if you picked a number past this value, what would it be? It will still be 1. Beyond this point, definitely 1. Great. Why is this important? I'm going to erase this. This table is what we call a cumulative distribution function, CDF. Put a star right next to it, because when we get to probability, you will see the CDF past the 4th chapter, maybe 5th chapter, all the way till the end of the semester. Keep on coming. CDF. That stands for cumulative distribution function. So we have percentages, first one maximum is about 33. So 2 out of 34 was about 5%, 6%. Look,
0.58.
yeah, I think it's 0.05. Yeah, so close to about 6%, which means probably somewhere. This just has to be approximate. I'm going to show you how to graph this using the calculator. 48.5, that's 3 out of 34. What was that equal to? 0.08. Three out of 34.
0.0294.
294. Oh. 0.294. Yes, it has to go down. 14 out of 34. 0.32. I'll probably put it somewhere over here.
3 over 34 is 0.08. Should be always going up.
0.08. 3 over 34. Where did you go wrong? No, where did you go wrong?
On which one?
3 over 34. It's okay. 23 out of 34. 0.6.
0.67.
6.7. Close to 0.7. 29 out of 34. 0.9 something. 0.8 exactly. 0.85. 0.85. Okay. 0.85 perhaps there. The next one is 1. Right. What we have there is just one. We just have to connect the dots. Starts at some value, let's just say at 0, and connect. So no. Counting strategy. Okay. So it's an increasing graph, it's always increasing. I didn't catch it from it after she said it was definitely pointless. I should have caught it. So this curve is going to keep on going. The maximum value is going to reach 1. That's a funny name. You know, it's called an Ogive. But by all means, the formal name for this is empirical. Let's see. Empirical because we got that curve from the data that we had, so it's empirical. And the other name for it is Ogive, not Ogive. Ogive. English is funny. I mean, if this were to be L, we would say olive, right? We would say olive. Oh well, there we go. So what is the purpose of cumulative frequencies? if someone asked you, well, what are the chances that a student's battery is at most 62.5? We wouldn't, look at relative frequency. I can just look right over here. At most would mean everything added up to 62.5, right? So I come up here and that would be the corresponding probability value. Yes, and what was that? From your calculator. 14 over 34. The advantage here is, well, we don't know exactly as to what the probability be if it is 95% charge, right? So we don't have that information, but 95 would lie somewhere here. Do we agree? So let's just say 95 is right over there. And if someone asked you, what are the chances that a student's battery, phone battery charge is at most 95, and that probability is about 99%, right? Based on the sample, what, yes?
Just had a quick question, just looking at the relative frequency, the 11 over 34, would that be 14 over 34?
No, it's right over here. You're looking at the wrong thing.
Oh,
That's relative, this is cumulative.
okay.
So all of these are cumulative frequencies. Based on this graph, if someone came up to you and asked you, well, what are the chances that a student's battery is going to be less than 10%, student's phone battery is going to be less than 10% at 3 p.m. On a school day? 0, right? So less than 20, probably it's over here. There's no curve. If you draw it back, it comes to 0. So there is no way, according to this data, it is impossible for a student to have a phone with a dead battery at 3 p.m. on a school day. Does that make sense? Would the same argument hold tomorrow if I get a different sample? May or may not, we don't know. But it will be close to this. So, Ogive, empirical savior. Are we clear? Yes. I'll show you how to compute this using your calculator.